Hi guys, so I'm gonna go ahead and make a video for the study guide. I'm gonna just go over the sections that I don't have a video for previously, which is inequalities, I think radicals, and the rational expressions. I think I did rational expressions, but we shall see. Okay, so inequalities. Number one. We need to solve, graph, and write each solution in set notation and interval notation. So for the test, you will be responsible to write solutions in set notation and or interval notation. Okay. So for this problem, first thing I'm going to do is I can distribute, but I mean, I could just move that term over to here, to the other side. And so I believe that is 102. You can distribute, but since these -6 and that binomial 4d plus 3 are factors, I could just divide this by -6. Okay, 4d plus 3, that dividing by a negative tells you that it's a U-turn, so it's going to flip the inequality. And then 102 divided by -6. Let's do that really quickly. 102 divided by 6 is going to be a -17. Subtract 3, 4d greater than -20. Divide both sides by 4. And I get d is greater than -5. Okay, and we can go ahead and plot that or graph it. It's going to be, and if you guys get confused with the inequality sign, just remember, always put whatever the variable is first as the subject, and you can just draw an arrow. It tells you where to go. Let's put it in set builder notation. So that is going to be a different color. That is going to be x such that x is an element of all real numbers and x is greater than -5. In interval notation, it's going to start at -5 but does not include -5, therefore the parentheses and the inequality, and -infinity. Okay, good job guys. Okay, once again I can distribute, but since it's factored out, I can go ahead and divide that entire thing by -8. And since this is a factor, that binomial is a factor, 2 minus 7x is a factor, then I could just simplify that. So I get 2 minus 7x, U-turn on the inequality sign, 264. Let's go ahead and 264 divided by 8 is 33. -33, and then subtract 2, -7x less than or equal to -35, divide both sides by -7, and you get x is greater than or equal to 5. You can go ahead and graph that. Equals 5, so it's going to be a closed circle. There you go. In interval, set builder notation, x such that x is an element of real numbers, x is greater than or equal to 5. In interval notation, we're going to start at 5. It includes 5, putting that bracket and a parentheses to infinity. Okay? Good job, guys. Okie dokie. So we have another one here. This one I have to distribute. Well, I could divide both sides by 8. This 8 right there, right here. But I'll get a fraction on the other side. So who likes a fraction anyways? So I'm going to go ahead and distribute. So 8x plus 7 times 8 is 7 times 8, 56. Negative 14 minus 2x. Let's go ahead and move the 2x to the other side because I just like moving positives. Okay, and negative 14. Deal with negative coefficients of x. I try not to deal with them. Okay, and 10x is less than or equal to 1070, negative 70. Negative 70, and then divide both sides by 10. So you end up with negative 7 is greater than or equal to x. And I'm going to go ahead and rewrite this as x is less than or equal to negative 7. Okay, and then let's put that less than or equal to, so it's going to contain all the numbers like negative 8, negative 9, and in set builder notation, x is an element of all real numbers such that x has to be less than or equal to negative 7. Interval notation, start at negative infinity on the left side and stops at 7 and includes 7. There you go. Okay, good job. Okay, next one. Here, a lot of kids get confused when there is a term outside. It's not just you. Okay, so I could actually rewrite this as 8. And notice that this is a term and that is a term. And that 3 has a negative. So I have to add by 3. But I can also rewrite this as something like that. Okay, and that is, what is that? The commutative property, okay, of addition. So I'm going to add 3 to both sides. I get 8, negative 2y minus 4 is less than or equal to negative 160. Divide both sides by 8. Notice that the 8 and the negative 2y minus 4, that binomial is a factor right there. So I can go ahead and divide the entire thing by. So I have negative 2y minus 4 is less than or equal to, is that negative 20? Okay, and then I'm going to add 4, negative 2y less than or equal to negative 16. Divide both sides by negative 2. So I have y, U-turn on the inequality sign, 8. Greater than or equal to 8. Let's go ahead and close circle. Greater than or equal to. There you go. Okay. Let's put it in set builder notation, x such that x is an element of all real numbers. This is y. Y is greater than or equal to 8. Have I been writing all of them as x's? Yeah, I have, even if the, yeah, but you know, it doesn't really matter. Okay. Yeah, I've been writing all of them as x's. On the test, they'll all be x. I think that was a question that was asked. Interval notation. It starts at 8, includes 8, and goes to positive infinity. There you go. Good job. So let's move on to absolute value inequalities. Okay, I talked about this in class. First, we need to isolate the absolute value. Okay. In order to isolate the absolute value, we divide both sides by negative 3. So we get the absolute value of 10x, negative 10x minus 2. Flip the inequality sign, but don't put equal to because it doesn't say that it's equal to. 54, that's going to be a positive 120. 24, 18. Okay, so absolute value inequalities. Some kids like to memorize. They like to memorize that a greater than or a greater than or equal to is going to be an or. It's going to be an or. Split up into or, and it's going to turn into greater than whatever the number is, and then less than, and then the negative of the number, and then less than or less than or equal to is an and so when you have it, it's going to be all of the things that are trapped, or it becomes a compound inequality. But instead of you doing that, if you understand that when you take an absolute value, of something, okay, you are finding the distance. So a distance could be 18. It has to be greater than 18. So if I draw this, and if I make that a, absolute value of a is greater than 18, it has to be greater than or 18. And the distance away from 0, we also have negative 18, but that's also 18 distances. This is 18. So it has to be away. It has to be bigger. So the next one is going to be 19 distances. Even though it's a negative 19, it's 19 distance, 19 units away. So that's why it turns into a or a union. So greater than 18 or negative 10x minus 2 is less than negative 18. So we have a plus 2 on both sides, negative 10x greater than 20 divided by negative 10. So x is less than negative 2, plus 2, negative 10x less than negative 6. Divide both sides by negative 10. X, and we're going to flip that inequality sign, and that's going to be 3/5. I'm looking at it, and somebody's going to probably want to, negative 16 divided by negative 10. Flip the inequality sign, so that's going to be 16 over both divisible by 2, so 8/5. 8/5 is roughly 1.36, somewhere around there. Okay. So our answer, let's go ahead and graph it. We're going to start at 2. It's all the numbers here. And then 1.6 is going to be somewhere here. And it's going to be all the numbers there. Okay. If I write it as set builder notation, all real numbers, and you can say x is less than negative 2 or x is greater than 8/5. And interval notation, we start at negative infinity to negative 2, does not include 2, and a union, and 8/5 to positive infinity. Okay? Good job, guys. Next. Okay, this is the one that when you think about, like, hey, this is as hard as an absolute value equation. I mean, thing comes, except for the cases, the special cases. There's some special crazy cases that that end up making the inequality all like one-sided. Okay, but this one, it's just algebra that gets to kids sometimes. And whenever I have a number like that, And this is a term right here, separated by a minus. And kids forget that there's two terms here, and then what they do is end up subtracting. Okay, no, you can't do that because you have to do multiplication first. When you're doing PEMDAS on this side, if you were going to do PEMDAS, you have to do the multiplication before you take this entire term right here and subtract it from 2. So one way to do this is to rewrite it. Rewrite this term as -3, -3t plus 6, and then it's a plus 2. Okay, or another thing is just to put a plus sign in front of it. So I'm going to subtract both sides by 2. 3, -3t plus 6. It's just making sure that was an x variable. Greater than or equal to -6123. Divide both sides by -3. I have the absolute value of -3t plus 6. You turn on that inequality. 21. Now, let's go ahead and look at this. Now, if I look at absolute value of 3t plus 6 is less than or equal to 21, I could treat it like absolute value of a. Everything inside is a. That's telling me, hey, I need a distance. A needs to be a distance that's smaller or equal to 21. So if we have 21 here, that distance from 0 has to be 21 or smaller. So it's all of this distance. Or, remember, this side, even though it's -21, this distance is also 21. So it has to be all of this also. So I take whatever a was, -3t plus 6, and I say, yes, it is less than or equal to 21. And I can take -3t plus 6, and it has to be greater than or equal to -21. -6, -6, -3t is less than or equal to 21 minus 6. I think it's 15. Divide both sides by -3. Once again, U-turn, and we have a -5, -6, -6, -3t greater than or equal to -27. Divide both sides by -3. T is less than or equal to 9. Okay. Let's check this out. Let's graph it. So we have a negative, and notice it's an and. And. So when you graph it, it'll help you out in looking at it here. We start here, and it's going to go this way. And then it has to stop at 9. So an and statement, it has to satisfy both of the conditions. It has to be greater than -5 and has to be less than 9 or equal to. To write that, t such that t is an element of all real numbers. And I can write this as a compound inequality. I can say t is less than or equal to 9, has to be greater than or equal to -5. Just like that. And then in set builder notation or interval notation, it starts at -5, includes -5, and stops at 9 and includes 9. And there you go. Good job, guys. Next, number 7. Okay, number 7. Let's see. The easiest way to do this is to multiply it by the reciprocal of 1/2. because we have a 1/2 down here. Okay. The reciprocal of 1/2 is 2/1. So I'm going to do that. And what you just created is a factor in the numerator. You just created a factor of 2. So you can simplify that 2. And then you end up with 1. So absolute value of 5, s plus 5 is less than or equal to 10. Now we have a less than statement, so it's going to be an and. It's going to trap this way, and greater than or equal to -10. Okay. And so it's going to trap the whatever's inside. So you can actually solve it if you know how to solve compound. Yeah, I don't think that looks like that. Less than or equal to 5 has to be greater than. This has to be greater than or equal to 5s plus 5. You can solve it that way. Okay. But that just confused you. I'm going to rewrite that. Okay, whatever 5s plus 5, it has to be less than 10, and it has to be greater than or equal to -10. Okay, so it has to be an and. So 5s plus 5 less than or equal to 10. 5s plus 5 is greater than or equal to -10. -5, -5. 5s is less than or equal to 5. Divide both sides by 5. You get s is less than or equal to 1. 5s greater than or equal to -15 by 5. S is greater than or equal to -3. And this is an and. So we have a 1 here and a -3 here. And it's going to be all of that in between. Okay, the way that we write it with set builder notation is say S such that S is an element of all real numbers. And it has to be, 1 has to be greater than or equal to S. And S has to be, no, that's not, I'm going to rewrite this. -3. And then less than or equal to S. S has to be less than or equal to 1. Compound inequality like that. And then on the left-hand side, we have a -3, includes -3. And on the right-hand side, we have a 1, includes 1. Let's see. And good job. Okay. We have one more here. And I just put one that confuses a lot of the kids. Once again, we have 2 terms. Put a plus here to indicate that's 1 term, and that's 2 terms right there. So I need to first get rid of the first term, -10. So I have an 8, absolute value, greater than or equal to 72. Divide both sides by 8. We have 2x minus 7 is greater than or equal to 9. Now greater than or equal to, meaning if I take a look, distance away from 0, it has to be greater. The distance has to be greater than 9 on both sides. So greater than -9. Okay, so it's going to be an or. 2x minus 7 is greater than or equal to 9. Or 2x minus 7 has to be less than or equal to -9. 7 plus 7. 2x greater than or equal to 16. Divide both sides by 2. X has to be greater than 8. Plus 7 plus 7. 2x 2, 2, 2. X has to be less than or equal to -1. Or, okay? Let's just see. Oh, whoops. What just happened? I don't know. Okay, now let's go ahead and graph that. -1, all of x has to be less than that, or equal to it, and then 8, equal to 8, and here. Okay, to put it in step builder notation, x such that x is an element of all real numbers, and x has to be less than or equal to -1, or x has to be greater than or equal to 8. If I write it as interval notation, on the left-hand side, we start with a negative infinity. We stop at -1, includes 1, union, start at 8, includes 8, and positive infinity. There you go. Good job, guys.